Good morning, everyone. My name is Corey Carlson with URETEK Holdings. Thank you very much for joining our webinar today. We greatly appreciate it. Very excited about today's webinar. We are going to actually have some customer testimonies, if you will, on some recent projects that we have done that have been successful. Customers have been happy, but they're also unique in the sense that it is a non-conventional solution providing significant economic savings for our customers versus conventional methods. And before we get started, I want to hit a couple webinar administrative comments. The first part of our presentation will be the City of Clarksville, Indiana, where we did a project where we fixed 7 sanitary manholes, and since then they have been able to save more than $100,000 per month in sanitary cost. Speaking will be Aaron Rogers. He is a sales engineer for us in Ohio, Indiana, and Kentucky. And then also Brittany Morgan, who is an employee with the City of Clarksville. She's the Capital Projects Coordinator. So for Clarksville, Indiana, after that part of the presentation, we'll open it up for questions. So until then, if everyone can just hit mute, please. And then we will open it up for questions. The next piece will be Jackson Lakes. Jackson Lakes is a very neat project because Escambia County was looking to rip and replace the box culvert. But we were able to come in with our chemical grout and lift the box culvert 24 inches. That is not a typo. We were able to lift a box culvert 2 feet and at the cost of 25% of the remove and replace. So a very exciting project. So Tommy Russum will be speaking. He is a sales engineer for us in North. Unfortunately, James has come down with, I think what many of us have probably got this this long winter, as from a cold standpoint, is a kind of a strep throat flu going on. So he is on the call. We'll try to have him talk if he can. I actually talked to him yesterday, and his voice is pretty darn bad. So specifics. We do offer a PDH for this webinar. You have to check with your state to make sure that it will qualify. We know for the state of Florida that it does not, but for other states, having success with it. After this webinar, we will then send a questionnaire out to everyone, and that is where you will select the box that you're interested in getting a PDH, as well as anything you want to hear about going forward. Before I hand it over to Aaron Rogers to talk on Clarksville, Indiana, I want to just kind of give a brief intro on URETEK Holdings, who we are, and really what we have been focused on as of late. We are a contractor who does work in the infrastructure, commercial, residential, government markets. We are headquartered in Florida, and we operate in 31 states. What we've really been focused on as of late, it seems, and we hear it every day, just on the cover of USA Today yesterday was talking about how 2,000 different municipalities are impacted by lead. And then you can hear different stories about the aging infrastructure. So there's just a lot of news in the aging infrastructure taking place, and so we have found that to be a great opportunity for us to provide our solutions to help customers really spread their money further. So instead of doing a remove replace, they can look at doing a rehabilitation. So in working with our customers, we have found this inside outside to be the right approach, where for a long time many customers were just looking at the relining of the pipe or just treating the inside of a manhole. Many of you on this webinar may have seen this exact article from Trenchless Technologies before, because it was a project of the year in March 2012. The manhole in Chicago was relined with permacast, which is a solution that we offer. It is a 10,000 psi cementitious liner that was applied to the manhole, but because the outside of the structure was never taken care of, the structural integrity had compromised. You can see what happened in the picture. The soil envelope around the structure collapsed. So we have been really working with engineers, municipalities to go after infrastructure and take care of both the inside and the outside. If you participated in our last webinar, this will be a brief recap, but for everyone else, I do want to share this slide. It is data points like this that is making us passionate about going after the infrastructure market. George Kurz, who's an independent consultant, spent numerous years here recently taking different daily reports from some different cities in Tennessee and came to the conclusion that in the state of Tennessee, his research is showing that 44% of the sanitary flow is actually I&I, actually inflow and infiltration. He presented a variety of different graphs that showed how it was tied to actually rain flow as opposed to usage. So the data just continued to show that inflow and infiltration was actually going through the sanitary lines, making up 44%, which is a significant amount of money that then involves taxpayers, that they have to pay for resizing of sanitary lines or pay for increased pumping rates because of this water that should not be there is having to be there. So we will solve these different problems with a variety of methods. I'll just give a brief overview of them, then we'll dive in these projects. The first one is URETEK, where we'll use a chemical grout to go on the outside of horizontal pipe or vertical structures, as you can see here by this graphic. So we'll take care of stabilizing the structure on the outside. Here's a recent project we've done in Dunlap, Tennessee, where we were able to take care of 3 different structures in just a half day's of work. And they have had significant reduction in their pumping costs as well, as we'll hear very briefly from the city of Clarksville. We've even had other infrastructure projects that have been just a nuisance to individuals. In Chicago, Illinois, we took care of a tunnel that was having water coming through the joints. And so using the chemical grout ejecting from the inside of the tunnel, we were able to stop their water inflow. Similar to the Jackson Lakes project we'll talk about, you see this project here from Alabama DOT. I love this picture because you see the before and after. The before shows a very dry culvert, box culvert invert, and obviously you see the after picture where now you have water flowing in the box culvert like it should. But by using chemical grout to create basically an injectable barrier at the entrance of this box culvert, we're able to get the water to go where it needs to go. Our material, due to its light weight, can also work in very old infrastructure, such as brick manholes. So now treating the inside of structures, we are a licensed applicator for Centerpipe and Permacast. Permacast is for manholes, Centerpipe is for the pipe. You see the picture on the right, that's a before and after picture. You can see a deteriorated pipe on the left, and then bringing it back to life and extending service life from 50 to 100 years, depending on the actual project. We'll treat the invert with the picture on the left. You can see how we've treated the invert, give it structural integrity back, and then we can either use a spinner or hand spray application to take care of the applying the mortar. Recent project, we partnered with a company called Baker Klein Engineering and worked on the Jacksonville airport, where we took care of the manholes, the I&I that was taking place there. We used a grout to take care of the I&I, and then used our Permacast to restore the inside of the manhole. As I mentioned, for center pipe, we can do pipe using a spinner, like in this example in Michigan, or you can do a hand apply for a very large diameter, like a 156-inch here in Florida DOT project. So a variety of different applications to meet customers' needs. The last item I'll mention before I hand it over to Aaron Rogers is Inversa. So we showed some solutions of the outside inside of what you can do once you know you have a problem. But we have partnered with a company in Versa who has basically brought to market like a CAT scan technology you see in a hospital. They have basically brought that to the civil engineering world, where they can literally see through pipes by a CAT scan process. So with the use of Inversa's technology, you can partner with municipalities and even consultants who are helping municipalities to take a look of the pipes that need to be rehabbed versus remove and replace. So you can do a prioritization of asset management. You can see a picture of the equipment here in the manhole or here in the pipe, and then a picture of what the CAT scan can look like. Inversa will then put together a kind of a map of what the pipe looks like, areas that are a concern, areas that are not, and a municipality will receive this map as well as some CAT scan pictures like here. If you look at the picture on the left, there is no void, there is no concern in that area. But then you can start to see that transition to a void and then the actual void itself. So that wavy line is the corrugations of corrugated metal pipe. But you can see there is a large void right there. So we'll be talking about that on our next webinar, May 6th, which we'll talk about at the end. Now I'd like to hand it over to Aaron Rogers, who will be talking about the Clarksville, Indiana project.
Morning, everyone. Like Corey said, my name is Aaron Rogers, and I was the project manager for a project we did just north of Louisville for the town of Clarksville. And we reduced I&I and had some really great outcomes with that. So that's kind of what the purpose of this section of the presentation is today. But I'm also the sales engineer for URETEK Holdings in the area, and today we also have Brittany Montgomery on the webinar, and she is the capital project coordinator for the town of Clarksville, and she was the person of contact and the project manager throughout this project that we did. So I'm going to be talking about the construction portion, and Brittany is going to be covering the city's, basically the whole project from the city's perspective. Costs, other solutions they looked at, and then the outcome and the finances. So we're going to start out with Brittany talking. So Brittany, I'm going to go ahead and pass it over to you.
Thanks, Aaron. As Aaron just said, my name is Brittany Montgomery. I'm with the town of Clarksville, and I just manage capital projects on our utilities and such. I'm trying to let Aaron. Okay. So real quickly, just an overview of the town of Clarksville. We have a population of about 22,000 people. We are literally just north of Louisville, Kentucky. This is a picture here I like to get out. It shows from our river view of the city of Louisville. We are relatively small populations as compared to our retail sector. We are considered the retail hub of southern Indiana. While we have a population of about 22,000, we actually serve during the weekends a population that'll quadruple, closer to about 70,000 due to our retail sector. The other interesting thing that they don't let me usually talk much about the town without saying is that we're the first settlement of the Northwest Territory, first settlement north of the Ohio River. And so we have a long history that goes back, a lot of very old infrastructure, but also a lot of new development that we have to continue to work with. Just a quick overview of our wastewater treatment plant system. We have a plant that was built in 1985. We just replaced it this past year. In June of 2015, our new plant went online. It's one of the last trickling filter plants here in the state of Indiana. Our average daily flow through our plant is right around 3 million gallons, which is typical for a community our size. However, during rain events, we would hit a peak of about 12 million gallons, and then we would overflow into the residential neighborhood across the street out of manholes. When we opened our new plant in June of 15, we went to an oxidation ditch, much cleaner water, better ability to treat that wet weather, and we also went to a wet weather capacity of 22 MGD, is what it's officially rated at. Within 12 hours of us putting the new plant online, we got a massive rainstorm, and we actually put 24 MGD through our plant. First time that we'd ever done that, not overflowed. We don't have any industry. Our last industry left in 2006, and so we are strictly residential and commercial flows. We have your typical warehousing and such, but we don't have a need for pretreatment. We don't have any real industrial facilities we have to worry about. Our collection system is typical for the Midwest. We have 72 miles of lines. We are very flat, except for the areas that are right at the river. So we have 35 pump stations. We actually operate on a header system where one pump station pumps into a different, and we have 3 main pump stations that then pump into a joint gravity line that flows directly into the plant. Our system's owed. We do not technically have a combined sewer system. We have separate sanitary and storm systems. Those were separated out when the initial wastewater treatment facilities came online in the 50s. Most of our lines are clay. We do have some concrete and some PVC in our newer developed areas. But I would say about 60 to 70% of our lines are the oak clay lines. Our smallest lines that the town actually will take care of is an 8-inch, and our largest lines are 36. The average is about an 8 to 12, except for more of our collectors. Our lines range in age. We have some that go back to more the initial development of sanitary sewer systems that are 100+ years, that when they separate everything out, continue to stay in line. But our average age is about 40 years. So we are facing the same thing that every other community, older community in particular, faces, and the fact that we have old lines, a lot of I&I problems. And I'm going to focus in particular on the area that we're going to be talking about where we did this repairs through URETEK. In 2007, the town started to notice increasing high levels at what's called Pump Station 10. Pump Station 10 actually has 5 different pump stations that go into it and service areas that go into it. But the issue with Pump Station 10 is it's sort of very rapidly growing retail area. This is an area, and it continues to grow today, where once a month we have new retail open. We have Walmart open, we have Target, we have Bass Pro come on. And suddenly the town itself was approving capacity letters for these new developments, but during heavy rainfalls we are seeing consistently high levels at Pump Station 10, and we are seeing consistent basement backups in areas in the neighborhoods that surrounded this development. A study was commissioned by H&B engineers, who are a local engineering firm, mainly in the Louisville, Kentucky area. And their results came back and said, you need to construct a new pump station. They don't know where the flows come from, but there's just too much flow, and you need to construct a new pump station and take some of the flow away from the current system and put it directly into the plant. However, as many communities at the time, our rates were very low, and the cost was not something that the council felt like they could move forward with. So the decision was decided to just kind of sit and watch and wait. Wait to see if any additional issues come up. Hopefully, the new development will make them put in some new lines and see what happens. However, we continued to have problems in the area, and not just in that area, but throughout the town. As you could see before, I said, during real dry days, we'll actually just put 2 MGD through our plant. We just don't have that much flow. But rainy events, we will put 12, and then we come out. We had some pump stations that were seeing a 500% increase in our flows during rain. And IDEM, which is the Indiana Department of Environmental Management, they handle all permitting on behalf of the EPA in Indiana. Started putting pressure on the town. You've got to do something to reduce your overflows. You've got to do something. Ironically, in 2011, the town was hit with a massive flood event, which caused our effluent line from the treatment plant to the Ohio River to fail completely. Because of that, there was a need suddenly to relocate our effluent line. We had to rebuild, complete the new treatment plant that just went online. And so the town entered into an agreed order with IDEM. I'm always careful to say we'd never entered into a consent decree. We never really had IDEM come down or EPA come down and say you have to do something. But because of the continued issues we had with overflows, IDEM snuck into our agreed order this idea that you had to spend $500,000 a year to reduce I&I. We had to go out and we had to start figuring out these problems. They weren't going to let us just kind of scapegoat on it. We weren't really in trouble, but they used this as an option to force the town to really start to deal with the problems in the collection system. And while at the time we weren't real sure how we felt about it, it worked out. Our first area of focus wasn't on the pump station 10 service area. That area, like I said before, has 5 pump stations in the large gravity area. That area is currently about 80% commercial and 20% residential. During wet weather, we peak over 3. We had the area smoke tested, and we were expecting to find that we were draining a field somewhere or something big, and we didn't find anything in particular. We just kept finding just small areas. So we decided to take the next step and we had to do something more. In the spring of 2014, there was actually an announcement that there was additional development that was going to come. They were actually going to develop some out parcels as well as put in a new nursing facility and retirement home in that area. At that point, we said we can't continue to sign capacity letters knowing that as more flow keeps going on, we have the potential to cause basement backups in our neighborhoods. We contacted GRIP Incorporated to complete a flow monitoring study. GRIP is just a local, based out of Indianapolis, community firm that does a lot of our flow monitoring for us. So we commissioned the flow study, and we started at pump station 10, and what we did was we just worked upstream. We kept moving the monitors. We used 2 meters at a time. After we get a good rain event, we look at them, we move them again. Just what everyone else said. We're just trying to track where it's coming from. And what we noticed was it looked like a pump curve. And so we were thinking, okay, one of the malls is pumping to us. They've got some pump, they've got connected, so we moved it past where they would have connected to the system. And what we found out was that we tracked it back to the gravity outlet of pump station 33. What we thought was an issue with one of our commercial developers actually ended up being an issue on the town side. Real quickly, pump station 33 is actually a station that was built in 2003. It's not an old station. The line itself is not old. It was built in an swampy area next to I-65. Interstate 65 forms our eastern border here in the town of Clarksville. And there were significant problems when the pump station and those lines were actually built. The initial contractor walked off the job and ended up going bankrupt because of the high groundwater conditions. When I say we're right off 65, I mean 65 kind of drains. They have 6 lanes at this point of I-65, and it all drains into this area where the pump station was. The pump station has 2 5-horsepower pumps rated at 1,450 gallons per minute. We only run 1 pump at a time. So it's a pretty typical pump station, but we had some issues from the beginning just with the lines. So our next step was to go out and have the line TV. So let's TV the line and see what happens. And we were really surprised actually at the results. Overall, the pipe itself was in good condition. However, the manholes and the joints were just leaking. And we had a TV during a dry period. Things were actually really dry. This wasn't spring. And you can see as the ground was dry, when you get down in the manholes, here's the water just seeping in. It was going 24/7. It wasn't just in rain events. And so we're like, okay, well, this is our problem. We have to do something to reduce it. The town examined several different solutions. Typically, we would have said, okay, let's line the manholes. We got an estimated cost. It would cost us actually about $100,000. These are really deep manholes. We have access issues back there. we actually had a lot of issues just being able to get back there and TV the line because of just where the location is. Also, no one could really give us a guarantee based on what they were seeing with the soil conditions that we could line the manholes and not have escape around the liners. We looked at what happens if we were to move the line from behind the businesses. This is off between Highway 31 and I-65. What happens if we were to move them out to closer to Highway 31? Well, there's significant cost with that, and the businesses wouldn't care for that, as well as we would probably have to actually put it in Highway 31, and we'd still have to run a pipe under 65, which is how it gets into the pump station 10 area. We looked also at just general CIPP. The line itself really didn't need it. We just needed the manholes. And so we just got to thinking, okay, what else can we do? There's got to be some better option here. Let's see. So the town's engineers, which are HDR Incorporated, they have their Louisville office. They had just had a lunch and learn from URETEK Holdings. And they said, hey, why don't we look at this? So he sent the results to Aaron. He reviewed them and said he thought it would be a good fit. And we're like, okay, this has got to be better than any other option. They gave us a cost estimate, and we approved it on the spot pretty well. We said, we've got to do this. What can it hurt? So the contract was prepared, and the okay was given. And we went ahead and moved forward with the repair. I'm going to turn it over to Aaron now to talk about what they actually did, what repairs they did, and how it ended up working. And I'll come back and tell you what the end results were for the town in just a second.
Thanks, Brittany. Give me 1 second here. There we go. Yeah, so as Brittany said, it was between HDR Engineering out of Louisville and the city of Clarksville. Kind of came together after that lunch and learn and agreed and liked our product and wanted to move forward with our solution. So first thing I'm going to talk about is specifically what the solution was. So we use a 2-part polyurethane grout, and the way that works is on our truck there's 2 separate materials, a resin and a hardener, and they're both in liquid form. And they run in separate tubes until they reach the injection point, which in this case is through the manhole wall. And if you look on the bottom left of the slide, you see the happens that causes the polyurethane to expand about 25 times the original liquid volume. So during that expansion, first the polyurethane is traveling into the voids, but anywhere that there is I&I or gushers, that polyurethane still in a liquid form is going to be carried in that flow through the faulted locations in the structure. So what you get is, because it sets up in about 30 seconds, the polyurethane does, it actually begins to set up as it gets carried through that faulted location. And what forms is outcroppings of our material as it sets up right along that fault. And once we see the outcroppings, we know that we now have what we call positive seal, or a seal that's now complete all through that fault. And a really important characteristic of the material for this job was that it's hydro-insensitive. And that just means that it's going to behave the same way in a bone-dry condition as it does in a saturated condition, or even beneath the groundwater table. So obviously with I&I and working around voids in the manholes, very critical to have that. And then it's also NSF 61 certified, which is great on every project. Just means you can use it around drinking water, which also means it's environmentally inert. And another piece of this that I think made the solution valuable was that we didn't have to bypass. So as you can imagine, we can do this with flow still in the system. So the project itself, basically we were given the CCTV results, as Brittany said, from the town, and we used that to kind of design our solution. So if you look at the table at the top of the slide, you can see basically all the manholes that we were going to treat. So there's 7 manholes. They're described as either major or minor repairs. And if you look a column over, you see the dimensions. So they're all 4 foot in diameter, but they're mostly deep. And there was a 12 foot and a 7 foot, but everything else was 17, 18, and then 21. And 21 was the one right next to the lift station. And then the repair types, there were 2 defects that were in almost every manhole. And that was, number 1, the precast joints. And you can see that in the picture in the bottom right. Water was traveling through there, creating gushers. And then the second defect was the pipe joint. So the pipe joint is the intersection between the 12-inch sanitary PVC line and the precast concrete manhole structure. And the picture on the bottom left corner, this is the CCTV going upstream in the line, and it's coming right up to the actual manhole. So you can see right at that joint the high pressures of that gusher. And again, the reason that we got high pressures and large gushers, we have a high water table and deep manholes. So hydrostatic pressure builds up. So the project itself, as Brittany mentioned, it's very close to I-65, and in some fashion or another, the water is unable to drain from the area, so it creates a very swampy area, and you can see all the cattails in the picture on the left. And this was actually the first manhole that we did when we got out there, and if you look right at the manhole, the groundwater table is about 3 or 4 inches below the lid. So that's the height of the groundwater table that we were dealing with. So you can see why I&I is becoming a big issue here. And you can also see our confined space entry equipment there as well. The other thing to mention during construction was access. And access is what had made a lot of the other solutions pretty expensive, as Brittany had talked about. And access for us, while a challenge, was also an advantage. But the situation was, you can see the picture on the right, you've got I-65, you can see the location of the manholes parallel to I-65, and then you've got US 31 to the right of that. So US 31 is the road that we access all these manholes from. So what we ended up doing is driving back behind businesses, parking in their parking lot, and because it's so swampy, we really weren't able to take any kind of, or our truck off of the parking lot areas. But we are able to extend our hoses, and this is how we do all our projects. So it turned out to be a very good fit because that's how we normally do work, but we could actually walk, deep into the swamp area with our hoses while leaving our trucks on the ground that's actually stable back at the parking lot. And then really the most challenging manhole we had was the one that was second to the top of that picture. You can see it's the only one that doesn't have a business development near it, but you can actually see the utility access road. So we had to use that, and the edge of that was in the swamp, and we had to get real close on the edge and kind of maneuver the truck around so that we were able to access that manhole. But our construction crews did a great job and got our truck back, and we were able to completely access that manhole. And this is a video. So yeah, if you look, you can see the I&I coming through right where the gun is inserted into the wall. And what we're doing is injecting the polyurethane behind that wall. It's filling the void and starting to seal. And you can already see the flow is reducing. And keep an eye on the 7, 8 o'clock position on the ladder area. What you'll see is I&I begin to form there, because what happens is, as you can imagine, water takes the path of least resistance. So as that happens, you're going to get new locations of I&I. So we always recommend to clients to encapsulate the full manhole with polyurethane, not just seal the one joint. And that was the case of what we did on all 7 manholes, was encapsulate the entire manhole, but you can really see it spraying now. And then just to describe a couple things in the picture there, you can see obviously our operator, and he is on a pulley system, and you can see The gun is inserted into the wall, and you can actually see the two separate tubes coming into the gun. Those are the separate materials, and that just gives you an idea of what the setup is here. And this was actually in the deepest manhole, but ironically, the gusher is only about 4 or 5 feet from grade. So a couple before and after pictures here. On the left, you can see at the invert, this is a lateral to manhole connection. You can see that we were able to completely stop that flow. And then the pictures to the right, before and after, this is actually the same exact joint that I just showed in the video. And what you see in the after picture is the outcropping, and I wanted to include that so you can see what it looks like when we get that outcropping and we know we have positive seal. And we clean that up before we move off site. So the work was completed in a day and a half. We did successfully stop all of the precast and lateral to manhole joints, all the I&I. And we didn't have to bypass pump, and actually we finished this project under budget. So I'm going to pass this back over to Brittany, and she's going to talk about kind of the outcome for the town as far as cost savings and different things like that.
Thanks, Aaron. I'm just going to finish up here the presentation just with telling you what our costs were and then what we saw in our savings. The total cost of the town was just under $75,000. Our largest cost was the flow monitoring cost, and that's because we were flow monitoring for about 4 months, and that's some significant cost. We don't have all those capabilities in-house. So those were at $54,000. Our engineering, and we paid HDR to look at some of the options and then also to provide the information to Aaron and all associated oversight of that. It was just around $4,000. And then our actual URETEK costs were $16,306. So we think about that. I mean, $16,000, as you guys know, you can't do a point repair really for that. We were able to fix all of our problems. As Aaron said, it came under budget. Initially, we were thinking it was going to cost right around between 20 and 25, but they bill us based on what they actually do, which is nice. And so then it came back and ended up only costing $16,306. And we were taken back. We're like, okay. After we got all these costs together, the next step was, let's see what really happened. Do we see any decrease? And it was immediate. We did this work in the summer of 2015. And we saw an immediate decrease. We had a rain event not too long after, and suddenly we didn't have the high levels at 10. We didn't have the high levels at 33. We were wondering, oh my goodness, this is amazing. So then we went back and we did the math, and what we saw was a decrease of over 10 million gallons a month being pumped. We don't have flow meters on all of our pump stations, so it's based on our hour meters. But to look and compare, we compare the same time frames exactly, and we also compared it wet weather versus dry weather, and to see that it was a decrease of 10 million gallons at both of the pump stations. We were just amazed. I'm not going to lie, we presented the information to the council, and they're like, we need to double check these. And so we had an outside engineering firm just look at the data and like, it was right. So our cost savings, and we based our cost savings on what we charge our customers, our regular metered rate. And so it saved us $94,000 a month is what we estimate our cost savings. And that's just based on the water treatment side of it. We also no longer had the need for a new pump station to service that area. That need is gone. We have adequate capacity on the system. We have double-checked that. And we can continue on with the full development of the area and not have to build the additional pump station. So that estimated savings is around $750,000. And that doesn't even really include land costs, which land costs out in this area where you'd have to build it goes for about $1.5 million an acre. So when you really add that up, our total cost savings has been, when you look at it, well over $1 million in the first year. We recouped our costs within that first month. And so I can honestly say that the project has been worth it. And that I would recommend this to anyone. I would say that's it. So I think that's really all we have on our presentation. Turn it back over to Robert for some additional questions.
Absolutely. Yeah, I've got a few questions, and I want to go in and mention. I noticed a few people have their hands up, just to try and make sure it's a little difficult to pass audio and all of that. So if you can, submit your questions in the questions section of your webinar toolbar, and that will you can ask the question there, and we'll ask them. But we got a few questions we're going to cover. The first. This one looks like it's for you, Aaron. Is the material able to set up under the groundwater table? And if so, what's your limitations there?
So yeah, as I mentioned, it behaves the same way in a dry condition or in a saturated condition. So this project was below the groundwater table, and what happens is during the reaction, no water is taken into the reaction itself. I mentioned the chemical reaction. And actually what it does is it just displaces all the water in its path as it expands.
And just to clarify the other portion of the question, was there is there any limitations as far as setup in a high groundwater area?
No, there's not any.
Okay. No, this question looks for you, Brittany. What was the flow to the pump station before and then after the fix? I think you covered that, but probably worth a review.
Yeah. So we base everything on our pumping hours, and before the fix, we were averaging pumping at pump station 33, 49 hours a week. We currently, afterwards, we're down to 17 hours a week. So we cut it in more than half, our pumping hours, and so then as such our pumping capacity and flow to the pump station.
Okay, great. One other question was, now you base you were basing your cost savings based on the rate. Do you feel that's a good way of valuing when also talking about your treatment costs?
We do. Our rates are set at our total costs, which include our bond costs and then our actual cost to treat and transport all of our wastewater. And with that being the such, we feel like that's a good way to look at it. I know other communities may view it based on the actual treatment cost, but we do a regular analysis of that, and our rates are set according to what it actually costs to transport and treat, plus our debt. So that's a good option, and we looked at some other options, but we still find that's the best. And when communicating that to citizens, they hear that because that's what they pay on a regular basis.
Okay, I'll just give it another second. That was the last of our questions. And again, if you want to submit a question, look within the webinar toolbar and you'll see a questions area there. There will be a time later in the presentation to ask questions about this project, but also about the Jackson Lakes project. So I'll just give it just one more, about 30 more seconds. Okay, just holding one more second. Here we are. It says, do you recommend lining the pipes along with the manholes?
I'll answer that one. I don't know who that was directed for, but it depends. You know, you can see in this project there was a huge cost savings because the pipes and manholes really didn't need to be lined structurally. After looking at the CCTV, the town of Clarksville and HDR Engineering out of Louisville both agreed that the pipes and manholes were in good structural condition, but they did need an I&I repair. So I would say in this scenario, just because of economically speaking, I wouldn't recommend both. But you know, does that mean 40 years from now you wouldn't need some sort of structural repair? You may. So it's project by project.
Okay, That seems, oh, here we are, one more. Have the pipes been TV'd after to gauge whether the stopping of the structure I&I has pushed I&I to pipe joints? And that's a follow-up question to the previous question.
That's a good question, and we've actually been kind of wondering that ourselves. We're coming up on the year mark, and we're talking about maybe doing that. We have to have we have a separate contractor. We have to come in and do our I&I studies and large TV work besides some of the day-to-day. And we've talked about having them come in when they're in for another project. Go ahead and CCTV that line again and see what's going on. See if there's been any other changes. We haven't seen any increases in flow since that initial work, and we are, like I said, about 9 months out. If we started to see more of that increase, I think we'd be more concerned. But we would like to see, just to see if there's other impacts it may have had, especially as we continue to look at using this technology throughout other areas of town. That would be a check that we would consider and are considering in the future.
All right, well, thank you for those questions. We'll go ahead and move along to our next presenter, Tommy Russum. Tommy represents us in Northwest Florida, and on this particular job, he'll be talking about a 24-inch lift of a box culvert. Tommy?
Yeah, great. Thank you, Robert. As Robert said, my name is Tommy Russum. I represent URETEK Holdings in the northwest portion of Florida. And we also have James Duncan in listen-only mode, I believe, at this point. He's under the weather and not capable of speaking. But he is the Deputy Division Manager of Escambia County. And we'll go ahead and get started. Escambia County is the westernmost county in the state of Florida. They have a population as of 2013 of about 305,000, and it was one of the first counties along with St. Johns County in the state of Florida back in July 21st of 1821. And we are home of the Blue Angels, which is pretty neat. A little bit of history of the box culvert itself is they're called Jackson Lakes box culverts. It's a quadruple barrel box culvert that is used to equalize the two southernmost lakes. It basically, as the lakes rise, it is there to dump the water into the adjacent creek, and then it'll flow out and dump out into the Bayou Chico. The original issue started back in 2012 when we had a severe storm that caused some flooding, and what this flooding did is it actually breached the top of the culvert and caused some erosion of the berm that was separating the lakes from the creek. At that point, the county tasked a local engineering company to do some assessment and develop plans for the repair. Those plans were generated, and as funding was being procured, we had a historic flooding event in 2014. This exacerbated the problem and eventually caused the collapse of this culvert. Once this culvert collapsed, there were some reassessments of the plans, and at that point, the engineer on record recommended a complete replacement of the culvert, which came to a budget of about $1.4 million. So those funds weren't available to actually do a complete rip and replace, so they had to kind of assess the situation and try to come up with another approach to this problem. Well, kind of along the lines of a timeline here, back in December of 2013, we conducted a lunch and learn with Hatchmont McDonald. Subsequent projects were completed with them that kind of gave them the confidence in what we were doing. Fast forward to April 2014, we did a lunch and learn with Escambia County. Alongside both Hatchmont and Escambia, we completed a couple of projects that gave them a little bit more reassurance that we were capable of doing what this Jackson Lakes culvert needed to be completed. A local engineering company also did a preliminary damage assessment, which recommended to the county to assess a technology such as ours as an alternative method as a other than complete replacement. I conducted my first site visit back in September of 2014, and as you can see by the picture, you can basically see the complete berm is gone around the culvert. It started to settle really bad at this point. It was a structurally an issue. The wing walls were gone. There was a lot of masonry repairs needed. But we did feel at that point that we were a viable solution. So I conducted a second site visit with Escambia County, collected the necessary information, designed a repair, attached a budget to the project, and we delivered it in December of 2014. Fast forward again to June of 2015, it was put out to a competitive bid. URETEK was the low bidder, and we broke ground pretty much in November of 2015. Now, several issues of this particular project was we had to get some subcontractors on site early to start to complete the massive dewatering job. We had to install a cofferdam. We had to make sure that the proper sediment barriers were in place, and the removal of the wing walls. URETEK's crews arrived on site December of 2015, and as you can see, what we're doing there is basically assessing the ground where it was at. It was a very mucky environment, real wet. The clays caused some of the guys to actually sink almost up to their hips in some areas. But we started the injection process December 1st, 2015. We basically installed a 4-foot grid pattern, multiple depths on the side of the culvert, as well as a complete grid pattern through the interior of 3 different boxes of the culvert itself. We used laser leveling, as well as a string line across from the high end to the low end to monitor the lift. As you can see in some of these photos here, this is our initial photo that shows the extent of the drop of the southwest portion of the culvert. 25 inches at its worst. Here's another view from the other end. You can kind of see the drop off and the extent of the water that we were having to dewater. Even with the cofferdam, some of the issues we had was there was water coming in all over the place. The picture to the left is showing you our rigs. It's basically all you need to get us going. You know, Aaron has already done a pretty good job of explaining our material. And one of the great things about our application is even if it's for an application like Aaron just described, or this application here, it's the same exact material. There's no really changing or guesswork in what we're doing. You see the guy on the left there is actually injecting to help contain some of the material. Here's a good shot of our guys showing our injections on our grid pattern inside with the laser levels. They're monitoring. We approach this lift with 2 rigs, and it has the capabilities of using 4 guns simultaneously. Now, as you can see here, we have the culvert lifted back up into place, and we're starting to use some of that backfill to actually bring back the area to where the creek is able to flow, and it's preventing the lake from overflowing into the washed out area that was previously there. Here's kind of some other side view pictures, and a little bit further back, we since have installed a fence, some sodding, and the one thing about this is the original budget of $1.4 million, we were able to go out there, lift the culvert, stabilize the ground underneath the culvert, do some preventative maintenance with some injectable barriers on both sides of the culvert, as well as upstream to prevent any water from flowing up underneath the culvert and eroding away the soils and kind of undermining the work we've done, as well as sod, fence. We even installed anchors to attach the cap of the culvert back to the walls of the culvert, and the masonry repairs for under a quarter of the original budget. Just kind of a recap, some of the design challenges we had were there was 20 inches of rain in almost less than 36 hours. So you know we're going to get heavy rain down here, so we want to make sure that we're not going to continue to go after this. It's going to become a problem in the future. So what we did is preventative maintenance. And if you're looking at the picture in the middle, the creek is flowing from the left to the right on a normal basis. During this high flood event, you get the creek changes its flow and starts flowing from the right to the left. This caused undermining of the culvert from the right side, completely up under the left side. So we knew we were dealing with about 2 foot of void space across, I believe it was estimated about 1,600 square feet. So we went onto the right side of the culvert and injected down below the mud line to ensure that we had deterred that water in the future if the flow had ever changed in another flood event. We had the backing of the county as well as dewatering professionals and the environmental group H2O. Here's some of the specifics of the job, and this type of information is readily available, as well as I do have James Duncan's information if you want to contact him directly to have him answer any particular questions about the county's aspect. But Corey, I can open it up to questions now and try to answer any questions. The lift itself, we started December 1st, 2015, and the complete 24-inch lift, the void filling of 2+ feet, and the stabilization was completed in 5 working days.
All right, thanks. We do have a few questions. So the first question is, were there any problems with breaking the suction between the bottom of the culvert and the top of the surrounding soils? And maybe even go further with that, the water underneath, right? So go ahead, please.
Yeah, that's a perfect question, and that is, you know, that really is what takes the most amount of the material is to break that suction. You could actually feel it when you were on the surface, because a lot of the guys, as you can see the picture of the right, were standing on top of the culvert as we were lifting, as well as the county's inspectors. And the first day we achieved 15 inches of lift, because once that suction was broken, that's your threshold. As soon as you get that broken, and you know, I mean, at that point it really becomes more of a surgical precision application, because you do have to kind of assess the movement, because it starts moving pretty rapidly. But yes, that was one of the concerns to begin with, but knowing the characteristics of the material, we're able to kind of manipulate it at the truck with pressures and turn up the heat so we get a faster reacting material. And kind of as Aaron alluded to begin with, injecting into water is never a concern with our type of material because it's hydro insensitive. It actually displaces the water. So we actually went down into the soil and to start our injection. So with that being said, we're actually lifting the soil as well as the culvert, which is the best possible scenario. So yes, there is a concern with breaking that suction, but if you're lifting the soil as well as the structure, you kind of alleviate that issue to a certain extent.
And is also part of that pushing out the water? Does that help as well?
Yeah, you want to make sure you get the water out. One of the things, you don't want any conduit for water to infiltrate your work. So you definitely start your injection from the upstream side. So as you're injecting toward the downstream side, you are displacing that water from underneath the culvert, as well as filling the voids.
That's great. Okay, so next question is, what sort of venting slash airflow would the work area, I'm sorry, let me try and re-ask this question. What sort of venting and airflow the work area was used, or what was used on the work area? Does that make sense?
Yeah, if you can go back one slide. Basically, as you can see, the guys in the bottom picture, it's an open-end box culvert. So if your question is about the guys and getting, we had forced airflow coming through there as they were working. But also, if you are trying to touch on the venting of the material underneath the culvert, we had multiple injection locations drilled and pre-drilled, so the material had a way to displace the water, as well as we knew we were getting communications between the injection points as we were getting material out of the adjacent holes.
Okay, great. I do want to pause here. It is 2 minutes past 12 Eastern, so I want to make sure that we're respectful of folks on the call's time. Corey, we will continue to ask questions. We've got quite a few more after this, but Corey, go ahead, please.
Yes, thank you very much for everyone who joined the webinar today. We greatly appreciate it. Special thanks to Brittany and James for their pre-work, putting everything together, as well as Brittany for speaking, and then James, we hope you do feel better. But our next webinar will be on May 6th at 11 a.m. Eastern. Our partners in Versa we talked about in the very beginning, they have a 3-step process, a visual, acoustic, as well as a CAT scan process, and their historical projects have shown that they can take a municipality, a DOT's remove and replace list, and actually convert that into 70% projects that only need rehab because the pipe is only in bad condition and the soil envelope just needs to be treated, as opposed to a whole remove replace. So a neat cost savings opportunity for municipalities, DOTs. So we'll be doing that on May 6th. So if you work with any of those entities or you yourselves are one, please join us for that. And then stay connected with us, please, via social media. And feel free to leave if you got to go about your day. But thank you very much for taking the time. And we will go back to answering some questions on the Jackson Lakes project, as well as anything for Clarksville, Indiana. But those who need to leave, thank you very, very much. And we look forward to working with you to solve some of your problems.
Okay, great. Thank you, Corey. Again, I want to go ahead and mention again, if you do have any questions, look in the toolbar for the go-to meeting, and you'll see in the questions section there an area to enter your question. Okay, so I'm going to continue. The next question is, what is the estimated weight of the culvert? How was it, what type of process you used to stabilize the soils at depth, and how deep did you inject the material?
All good questions. For estimation purposes, the weight of the culvert wasn't really a factor. If you understand the characteristics of our material, we've done a lot of projects worldwide that the weight was, we've lifted a lot of objects worldwide where those particular things were a lot heavier than this culvert was concerned. The depth of the injections were just below ground surface, just so we knew we were actually into a stable environment. One of the things with lifting, you have to make sure what you're lifting off of is stabilized. This particular project didn't have a lot of engineering beforehand. It had damage assessment reports, but it didn't have any borings to let us know what we were dealing with. However, the mud line of the lake and the adjacent creek was approximately 9 feet from the top of the culvert. So what we were able to do is kind of take the depth of the culvert and kind of extrapolate the information based on void space. We ended up going in, I believe, 4.5 feet from the base of the culvert. That's where we found the stable soils capable of this type of a lift. And
Great. Even though that the weight wasn't a factor, is there an estimated weight of the culvert?
I don't have that information with me at hand. I can follow up with that question if you want to just provide me with the contact information.
Sure, will do. Okay, next question is, with a plus or minus 2 inch of settlement, did the culvert experience any structural damage, cracks, etc.? And there might be
Yeah.
images of that. Is there not in the presentation? Go ahead, Tommy.
Yes, there was definitely some cracking. The cap of the culvert was a post-tension cable reinforced. The culvert itself had some pivot point cracks where it actually settled. And along with this repair were the structural masonry repairs of the culvert itself. We also went in on a grid pattern and attached the cap of the culvert to the bases and the upright walls of the culvert with 1-inch Hilti anchors. And yes, I do have plenty of photos of the pre-installation, during installation, and post-installation if anybody's interested. But to kind of condense it all down into the webinar's available time, I just put the pictures in the webinar that we had.
We've got some hands up. I'm going to attempt to unmute and see if we can do this. Mr. Chilton, are you able to speak? Did you have a question? That's for Paul Chilton or Charlton. Okay. Yeah, I'll go ahead and mute real quick. Here's another question. Has this material been applied to repair structural foundations or residential or other buildings where flooding has occurred?
Yes, it's a great question, and it's used almost on a daily basis down in the Central Florida area. It's been used to not only just stabilize foundation soils, but also, if it's necessary, of course, it's a project-to-project basis, but we've also been able to lift foundations with our material. But it's a very high utility material. If you have more of a specific application for us and you want to forward that to us, we'd be happy to take a look at it.
Be great. I have a couple more here. One second. How do the oh wait, I'm sorry, here it is. Are you concerned about water coming underneath the box culvert again?
That was definitely one of our concerns. In Florida, especially this part of Florida, we are experiencing more and more rain as the years go by. Kind of what we've done and what we have to look at is what conduits or what avenues this potential water could run through. We know that it's going to come from the upstream side, so what we did is we went upstream and we injected through the apron of the culvert on a 3-foot center across all 4 barrels just below the mud line, and we injected those areas until we got a bump at the surface. And what this tells us is that we've got the soil and the material at such a close-knit network of matrix that we've almost created a monolithic mass or a damming effect that will prevent water from eroding up underneath of the culvert. We've also done that on both sides of the creek. With this particular problem, we knew the history of it and we understood where the water came from. So we did some preventative maintenance measures after the lift was to inject what we're calling an injectable barrier along both sides of the culvert. And this is going to prevent any future erosion or undermining of the culvert itself. So yes, that was a concern, and we did take the preventative maintenance action to alleviate that issue.
This next question was, the lift was 24 inches on the culvert. Did that have to be done to help level out any particular side, or was it an even across lift? Or did you, such as having more material in one corner, or was it a consistent lift all the way through?
Yeah, it was a two-stage lift. Okay, back in 2012, the undermining and the erosion occurred, which did cause the culvert to settle across the four barrels on the, if you're looking at it, the culvert is upstream side is going to be east, downstream sides on your west, the creek's flowing from the south to the north. So the west side of the culvert settled as a whole, and then just a little bit, but then the storm of 2014 finally eroded it and caused it to actually fall away the 2+ feet that we seen when we started the work. So what we did is we went in there, we injected at the southwestmost corner with 4 guns to lift that first stage of the back up level with the whole culvert itself. Then we adjusted ourselves and our spacings out to start lifting the whole culvert, but it was not a complete 156 feet, I believe the culvert is in length. We were really just dealing with about 11 or 1,200 square feet of a culvert where it's separated at the southwest corner of it.
Okay, one more question. Is the material susceptible to deterioration from freeze-thaw cycles?
Being down in Florida, I don't really have freeze-thaw cycles as some may have in the northwest area. I do know there's some applications that we are using this material to help alleviate that.
Maybe we can have Corey or Aaron address.
Yeah, maybe Aaron might be better up in his area.
Aaron, you're on mute, or Corey.
Yeah, this is Corey. We do not have issues with freeze-thaw throughout the cycle, throughout the year. What we do take note of is installing the material. We definitely are mindful of the temperatures when we inject the material. Where is the water table during while we inject? If it is in freezing conditions, if it is in frozen conditions, we don't want to inject above the that freeze-thaw level. So if we're doing a project where we're going a couple feet below the ground, then we are comfortable doing that. So that's the only really thing we consider for freeze-thaw is the actual installation itself. But once we've installed our material, we are comfortable with how it will perform around the entire year freeze-thaw. We do projects in the northeast, northwest. This material is used in Canada as well, so it definitely has been in many cold areas. And in a future webinar, we'll even actually share some projects that we have done, whether it's a Amtrak tunnel that we did in Baltimore, Maryland, and then we just did some neat projects up in the New York area as well that we can share.
And one of the things I would just add to that is if you understand the characteristics of our material, it displaces water. So we would need to gain as much information on a project as possible, moisture content of the soil, groundwater level, and then we can design an injection plan. As we're injecting the material, it is displacing that water, which should alleviate most of the freeze-thaw issues. But it is, again, it's a project-to-project basis.
Okay, thank you. Well, that seems to be the end of the questions. For housekeeping, again, we'll be sending out an email after this webinar is ended. It'll give instructions on going to a feedback form. Through that form, we'll gain whether or not you need a PDH certificate, and then give about 5 days time for you to receive your PDH certificate post the webinar. That's it for my notes. Corey, if you want to take over.
Yeah, once again, thanks everyone for participating. Aaron and Tommy, thank you, as well as Brittany and James for your guys' work. Very neat projects. Exciting to kind of even relive them, just hearing them again. So Please keep us in mind if you have any I&I issues, different projects. Let us know. We'd love to work with you and solve some problems and give some of those cost savings that we were able to provide to Escambia County as well as City of Clarksville. So thanks, everyone, and look forward to staying in touch. Thank you.